how do we send ones and zeros through the air? How do we translate radio waves or that energy into the air into ones and zeros? We do it through a process called modulation. Let's take a look at these two different radio waves I have on the left here, and the one at the top is shaped a little differently than the one below that, and the one on top is equal to, consider the one on top to be equal to a 1 and the one below that to be equal to a 0. So with that said, the two slightly different shaped radio waves are kind of just strung along there, and then you have a modulated signal of ones and zeros being properly transmitted through the air. Great. Now, how are they received? How do we get those radio waves to where they're supposed to go? We use that through a process called quadratic amplitude modulation, or QAM. If we take a look at this little target here we've drawn with these 4 different quadrants, if we're trying to send a specific piece of data that's supposed to land in this quadrant, it will land in that quadrant, and so on and so on. If we're able to, let's put it in terms of shooting. If you have a big enough target and you're like, hey, no problem, I can hit that top left corner of that target pretty easily, or I can hit that bottom right part of the overall target with some relative ease. Okay, so the larger the target, the easier for the radio waves to be received. The issue with that is you're going to have less amount of targets to be able to hit, so you'll have less data rate. So with something like Ethernet that's hardwired, that's a constant data rate. Your link speed, if you're getting a 10 megabit speed through Ethernet over fiber, or just connecting through twisted pair cabling or whatever, and as long as you've done your cabling correctly and you're supposed to be getting a 10 megabit per second speed, you're going to get that, and it's going to stay that way. But within Wi-Fi, it's a variable rate. It can vary depending on the QAM of how many targets exist within those quadrants, and also on external effects like noise and interference, which we'll get into in a little bit. But how do we increase those data rates? Well, we need to put smaller targets into each quadrant, so we have more targets for those radio waves to hit. So the more precise and the smaller targets, the higher your data rates are going to be. Now in this example to the right, I have 4 smaller targets in each quadrant for a total of 16. So that would be 16 QAM, or 16 bits, for the total of for the total of the target set itself. Now you can increase that and double it and take it to 32 QAM, which would be 8 smaller targets within each quadrant. And within 802.11ac, which we've talked about in previous videos, that is up to 256 QAM, or 64 small targets per quadrant. Really impressive, and that's what gives that huge data rate within 802.11ac. One of the key things that gives that massive data rate within 802.11ac. But like I said, what prevents or degrades those signals from landing in those tiny little targets? Well, interference and noise. Noise is always something that's a little bit ever present in the airwaves. That could be it could be trees, it could be things that operate and function on around that same radio frequency that you're attempting to transmit within. And interference is actually the same radio frequency that is causing actual direct interference with the signal that you're transmitting. So both those things, and it could be a different device in the area that's transmitting on the same frequency that is causing that interference and causing those radio waves to prevent themselves from making it to their destination at the receiver within that QAM target set. So what I want you to take away from this is how signals are shaped or modulated and transferred into ones and zeros, turned into ones and zeros over the air through the shaping of a radio wave, and how they're received by a receiver, and how we can maximize the amount of those radio waves that are successfully received by that receiver. So I hope that all helps, and hope you enjoy this video, and I'll see you on the next one, okay? Thanks.